Today we're going to have a lab named Matter in Motion Virtual Lab. Your objective is to investigate the relationship between speed, velocity, and acceleration. Directions. Log on to my NISD.NISD.net portal. So you guys are going to open your portal and you're going to click on the Think Central icon, which is going to open the online textbook in a new tab. So I'm going to go to my NISD portal, and here is my Think Central. I need to click on that to open my textbook to open my lab. Now with my Think Central tab open for my textbook, I can go to my lab now and my lab will open up. Okay, we're going to click on the following link to access the virtual lab. So if I click here, it's going to open up the virtual lab.
To analyze the data you collected. First, look at your results. Welcome to the lesson, Speed and Velocity. In this lesson, you're going to investigate how speed, velocity, and acceleration are related.
And I'm going to click on this arrow to turn the page.
Melissa raced to the mailbox to mail a letter. If it took her 2 seconds to ride from the lamppost to the mailbox, how fast did she bike? Click the correct answer and then click OK.
So speed equals distance divided by time. Her distance is 10 meters divided by her time 2 seconds. 10 divided by 2 is 5 meters per second. So I'm going to click on this answer and hit OK.
Good job! You determined Melissa's speed, or how fast she biked from the lamppost to the mailbox. To find speed, divide distance by time. How would you describe the motion of this race car? You could describe its speed or velocity. Click play to review the difference between speed and velocity. Speed describes how fast an object is moving. An object's speed is distance divided by time. This race car might be moving 25 meters per second, but its speed changes whenever it moves faster or slower. Click play again. Velocity describes an object's speed and its direction. The car's velocity might be 25 meters per second east, but after it turns a corner, its velocity might be 25 meters per second south. Anytime the race car changes direction, slows down, or speeds up, its velocity changes.
Click the arrow to turn the page.
In this lesson, you will investigate velocity as you drive a boat from buoy to buoy around this small lake. You will need to change your speed and direction from one buoy to the next. Where the water is smooth, you can travel fast, but where it's choppy, you must slow down a bit, and where it's marshy, you must travel slowly. You will record data about distance, time, and direction. You will use this information to find speed and velocity. Here's what you'll use. A boat. You will drive this boat clockwise around this lake, starting at buoy A. Direction and speed settings. You will use this knob and slider to set the boat's direction and speed. The highlight color around the buoy tells you how fast you can go toward that buoy based on water conditions. Green means fast, yellow means medium, and orange means slow. Distance and time data. You will find the distance and time you traveled between buoys. Data table. You will record distance, time, and direction in the data table. You will use the distance and time data to calculate the speed. Then, you'll use the direction data to record the velocity.
And I'm ready to turn the page.
The boat will travel at a different speed and direction from buoy to buoy. How will the boat's velocity change between each of the buoys? Type your answer and then click OK.
So my velocity is going to change when I change direction. So when the boat turns is when my velocity changes. So boat's velocity changes. How will the boat's velocity change between each of the buoys? Okay, velocity will change when the boat changes direction.
Continue to see if your prediction is correct.
So I will press the arrow to continue.
Now, describe your plan for measuring and recording how the boat's velocity changes between each buoy. Record your plan in the box. When you're done, click OK.
So I will record distance and time and record my direction.
Check your plan. Did you set a goal and include these steps? Set the boat's direction and speed to travel from one buoy to the next. At each buoy, record the distance, time, and direction you just traveled. Use distance and time data to calculate the boat's speed. Then use direction data to record the velocity. If your plan does not include these steps, you can change it. Once you've finished, click the Next button to move on.
So I'm going to click the Next button.
Now, follow your plan to find how the boat's velocity changes as the boat travels from buoy to buoy. Let's start by collecting data about the distance, time, and direction for each part of the trip. Then, repeat these steps for the remaining buoys. When you have completed the trip and filled the data table, continue to the next screen. Turn the knob to set the direction the boat will travel from buoy A to buoy B.
Okay, so I will do the first stage with you, and then you will continue on the next stages on your own. So what I need to do is I want the boat to go from buoy A to buoy B. So I'm going to use my compass over here to point in the right direction.
B tells you to go slowly through the marsh. Click the Run button to start the boat.
Now that I'm in the right direction, east, I'm going to set my speed. The highlight tells me I'm orange, so I'm going slow. So I'm already ready to collect data, so I'm going to hit play.
Find the distance and time that it took to get to buoy B. Record the distance, time, and direction in the data table.
So my distance is 17 meters, and I'm going to record that there. And I'll put a lowercase m, and my time it took me was 34 seconds, and my direction according to the compass was east. Okay, so you're going to do that for B to C, then C to D, then D to E, and then E to A. I'm going to hit next, and you're going to do the rest of the lab on your own. Don't forget your assignment.
You can click the reset to repeat the entire investigation.
You need to scroll down to record your data that you did in the lab. So make sure you have this tab open so you can record your answers here. Okay. Okay, so I'm going to, actually I'm going to pause the lab here and I will let you guys complete that. And don't forget you have to put your data here and then you're going to analyze your results. So here it's asking you, how did the velocity change between buoys? So you should be discussing how when the boat turned you were changing direction, so your velocity was changing. What are your 3 different ways an object might accelerate? Remember, your boat can increase speed, decrease speed, or change direction. So put a definition down for speed. Speed equals distance divided by time. Velocity is speed with direction, and acceleration is when you change your velocity or your speed. For your short answer questions, it's asking you to calculate the average speed of the boat from start to finish. So your average speed is the total distance divided by total time. So you want to take the total distance divided by the total time to get your average speed. So you can add these up from your trial and divide, then add these up and divide to get your total distance divided by total time. Here it's asking you, a bus travels 20 kilometers in 30 minutes. What's the average speed of the bus? Careful on this question because your answers are in hours and your time up here are in minutes. So you have to convert these minutes to hours. So if you double this, you have to double that. Number 8, which of the following best describes the velocity of an object? Remember, velocity is speed with a direction. You are a train traveling 100 kilometers per hour, 63 miles per hour. Do you know the train's velocity? So here you're just given the speed but not direction. What is the difference between velocity and speed of an object? Remember, velocity has no direction associated with it, while speed has a specific direction associated with it.